Welcome back. This is part 2 of this lesson. We're going to continue immediately from the end of part 1, so let's get started. Now we're going to do something a little bit more complex. So both of those examples were where we actively executed the Lambda function. We manually did it. We did it from the user interface. But let's now look at an event-driven workflow, how we can get a Lambda function to react when something occurs inside the AWS account. So we're going to go ahead and create another Lambda function. So move back to the Lambda console and go to functions. And this time we're going to create one called EC2 protect. So create function, author from start. The function name is EC2 protect. Then click on the runtime dropdown and pick the runtime as I've included in the description for this lesson. Then scroll down again, expand change default execution role. Pick to use an existing role, click on the drop down and select the IAM role that you created earlier in this lesson. And once that's set, scroll down and click on create function to create the Lambda function. Also attached to this lesson is another file called 03_lambda_instance_protect. So what I want you to do is to copy all of this into your clipboard. Now this function is slightly different. This function receives an event. We're going to run this function whenever an instance is moved into the stopped state. And what this function will do is accept the event data, which is this, and from that event data, it will determine which instance has been moved into a stopped state. So it will look inside the JSON, inside detail, and then inside instance ID. It will get the instance ID, and it will immediately run start instances to start that instance back up. So this is an example of a function that can run in an event-driven way. So copy that into your clipboard, move back to the Lambda console, and then just scroll down, right-click on lambda_function.py on the left and select Open. Select the existing skeleton code and delete it, and then paste in what you've just copied into your clipboard and click on Deploy. Now this time, because we're running it in an event-driven way, we won't be supplying the list of instances manually via an environment variable. Instead, we'll be creating a rule inside EventBridge. And that rule will monitor the event bus for this account, and whenever it sees a specific instance move into a stopped state, it will trigger this rule, pass this event through to a target, and the target will be this Lambda function. So when an event happens that a specific EC2 instance that we're protecting moves from running to stopped, it will generate an event. The event bus will be monitored by EventBridge looking for that particular event. When it finds that event, it will pattern match that event and it will restart the EC2 instance. So let's look at how that works. So I've created EC2 Protect now. Next, I want you to click on the Services dropdown and just look for Amazon EventBridge, right-click and open that in a new tab. So we're going to create a rule inside EventBridge. So click on Create Rule. We're going to call the rule EC2 Protect. And for description, we'll type Start Protected Instance. Now this rule will be an event pattern rule. So click in Event Pattern, click on Next. Now this event rule is going to take effect whenever an EC2 instance changes state, and so for event source we need it set to AWS events or EventBridge partner events. So go ahead and make sure that box is checked. Then scroll down. We're going to come back to this sample event in a second. What I want you to do is move down to the bottom and look within the event pattern box. The service that we're going to be looking for is an AWS service, and the service name, of course, is EC2. So scroll down, and we're looking for EC2, select that, and the type of event that we're looking to monitor and react to is an EC2 instance state change notification. So select that. Now to make this slightly easier to understand, if you just scroll up and under sample events, go ahead and type EC2 into the sample event search box. and then scroll down until you find EC2 instance state change notification and go ahead and click, and this will generate a sample event. This is the type of event that you'll see when this event rule is operating in a production setting. This is the type of event that will be generated whenever an EC2 instance changes state. So this is the event that will be captured by this rule and delivered to a target that we choose. So you get all sorts of associated information, such as the source of the event, the date and time of the event, the region, as well as the resource that's being affected, and then under detail, we'll see the instance ID that has been changed and to what state it's changing into. So this is the important information that will be used by our Lambda function. Now we only want this rule to trigger when an EC2 instance moves into the stopped state. So we want to filter this a little bit more than any state, so click on specific states and in the drop down change it to stopped. We want this rule to trigger when the state of an EC2 instance changes to stopped. We also only want to protect a small number of instances. We don't want to protect them all. So click in specific instance IDs, and what I want you to do is to copy the instance ID of instance 1 into your clipboard. Now you should still have this, but if you don't, you can always go back to the EC2 console and just copy down the instance ID of instance 1. And you need to make sure you're using your instance 1 ID because it will be different than mine. Once you've got that instance ID, paste it into the box, and this means that this rule will only trigger when this state is reached on this particular instance, so only for instance 1. Click on Next, and it's here where we can select one or more targets. Now any events that this rule captures will be sent to all of the targets in parallel. Now if you only have one target, this doesn't matter, but if you have multiple targets, keep in mind it's done in parallel and there is no ordering, so every target gets the event at the same time. So we want a target to be a Lambda function, and we want to use the EC2 protect Lambda function. So go ahead and select EC2 protect, and that's the only target we want to use. Click on Next, move on to the next screen, and then go ahead and click on Create Rule to begin the creation process of this event bridge rule. So that rule is now active. It's monitoring the default event bus of this AWS account. So let's have a look at exactly how it works. So if we move to the EC2 running instances screen, just refresh to make sure we've got the latest view. Now select instance 2, right click, and then stop. Because we've not defined this as a protected instance, we've not added it to the list of instance IDs that are protected by the event bridge rule that we just created. Well, this instance will be able to move from running to stopping and then finally stopped, and there'll be no effect. It'll remain in this stop state indefinitely. But because we have set instance 1 as being protected, we'll watch what happens if we try to stop instance 1. So right click and then get ready to click on stop. Now remember, as soon as I click on stop, what's happening is an event is being generated by EC2. It's an instance state change notification event. That will go onto the default event bus for this account. There's a rule which is monitoring that default account event bus. The rule is looking for this instance ID, and when it sees that rule, it's going to send it to our Lambda function. It will invoke our Lambda function. It will pass in this instance ID. So go ahead and stop instance and then confirm that stop operation, and then just look at exactly what happens. So it's currently in a stopping state. Keep refreshing it in real time. It says stopping still. Going to keep doing this over and over again. It's important that you see how this works in real time. Now it's moved to pending. So what actually happened is it moved into a stopped state, and then immediately once that happened, that event rule triggered and it caused our Lambda function EC2 protect to be invoked. And that Lambda function, its sole responsibility is to start any instances that it sees in the event data. So if we refresh again, this protected instance has now moved back into a running state. So that was a very simple example of an event-driven workflow. Now, if we click on services, let's just look at exactly what's happened. So we're going to move to CloudWatch logs. So type CloudWatch, and open that in a new tab. Lambda functions by default log their output into a log group with the same name as the Lambda function. So if we just scroll down, we'll see a log group called /AWS/Lambda/EC2 protect. And this log group will show all invocations of this particular Lambda function. So let's go into that log group. You'll have a log stream for each time period. So in this case, there's only one because there was only one invocation. So let's click on that and we'll see an output from the invocation of our Lambda function. Now I've got the Lambda function to actually do a print of any event data that it receives. And this is the event data that it gets passed through to it when it's invoked. So it's just a simple JSON structure that lists the details of exactly what happens with the event. So this is the event data that's taken by EventBridge and delivered through to this target, which is a Lambda function. And the event structure differs depending on what service is generating the event and what event it is. But they all follow a similar high-level structure. They all have an ID, they all have a detail type, they all have a source, they all have an account and a time and a region. The rest of this depends on exactly what service is generating the event and what event it is. So that was a simple example of an event-driven workflow. Now we can actually do more. If we go back to EventBridge, we can create another rule, and we're going to call this rule EC2 stop. This is going to be a rule which stops EC2 instances inside our AWS account. So let's just go back, and what we'll do is start instance 2. I want to show you how different rules can compete with each other to do the same things. So I want us to move into a position where we've got two running EC2 instances. Remember, one of them is protected by this other pattern matching rule. So if instance 1 is ever shut down, it will automatically be started up. So we're going to create a second rule that's going to be a scheduled rule that's going to stop EC2 instances at a particular time of day. So instead of using a pattern matching rule, we're going to create a schedule rule. Click on Next, and you can set with a schedule rule either to run at a fixed rate every either hours, minutes, or days, or you can specify a cron expression. And this is what a cron expression looks like. Let's just paste in one as an example. The first field is the minutes, the second field is the hour, so this is 50 minutes past 8 a.m. The third field is the days of the month, the next field is the month, the next field is the days of week, and the next field is the year. So in this particular case, this would run every day at 50 minutes past 8. Now, it's important to understand that this is in the UTC time zone. So what I want you to do is to go onto Google and type what time is it in UTC. So in my case, it's currently 00:31 UTC. So 31 minutes past midnight in the UTC time zone. So I want you to create a rule which runs in a few minutes time. So in my case, it's 31 minutes past midnight. So I'm going to create the rule to run in approximately 4 minutes time. That gives me just enough time to explain the rest of the configuration. So you should take your time in UTC and just add a few minutes. And cron is in 24-hour format, so you need to both pick a time in a few minutes and make that conversion. But you should choose a time that's relatively close to the time right now in UTC. So scroll down and click on Next. The rest of this is exactly the same as a pattern matching rule, so we need to select a target. So make sure AWS service is checked. Click in the Select Target Type drop-down and locate Lambda function and select that. And then under the function drop-down, go ahead and pick EC2 stop, because what we want to happen is when this schedule rule triggers, we want it to stop the EC2 instances. Once you've got all of that configured, scroll down again and click on Next. Next again to move to the next screen, and then scroll down and click on Create Rule. So this rule in my case is going to run once every day, which is in exactly 2 minutes time in my time zone. Now just think through what will happen when this occurs. So firstly, this EC2 stop rule is going to trigger in a couple of minutes. It's going to run the Lambda function, EC2 stop, and that Lambda function will run against both of the instances that we've set it to run against. Remember, we declared an environment variable and we gave it the two instance IDs of our EC2 instances. So in 1 minute now, in my case, it's going to run against both EC2 instances. So I'm going to move to the instances console, and I'm going to begin hitting refresh so you can see exactly what this looks like. So this first rule is going to trigger the Lambda function EC2 stop is going to be invoked. And that's going to move both of these EC2 instances into a stopped state. They're going to go through stopping and then they're going to move into a stopped state. So now they're both moved into a stopping state. Now keep in mind that this is a rule that's triggered and it's run this Lambda function and it's changed the state from running and they're moving now into a stopped state. But in doing so, both of these instances generate an event. And remember, we have the other rule which automatically looks if instance 1 moves into a stop state, and when it does, it runs the EC2 protect Lambda function, which moves it back into a running state. And there we go, we can see that process has occurred in real time. That Lambda function stopped both of these EC2 instances and both of them actually reached a stop state. Both of those instances generated an event on the event bus when it went into each individual stage. But we also have the rule EC2 protect, which is looking if instance 1 moves into a stop state, and when it does, it runs the EC2 protect Lambda function, it delivers that event, and that starts up instance 1 again. So now you've just seen two automatic event-driven rules operate one after the other. One of them stopped both instances and another one started up instance 1, which is protected. Now this has been just a gentle introduction into exactly how Lambda, how Event Bridge, and how event-driven architecture works. It's a simple example, but it's something that you can use in real-world production accounts for much larger and more complex systems. But that's everything I wanted to cover in this demo, so we do need to perform some tidy up. So first, go to the Lambda console, and go to Functions, and delete each of these functions one by one. You don't need to worry about the order, just make sure that you delete each of them. So start, stop, and protect. Once you've done that, go to Event Bridge and delete both of those event rules that you created. Again, the order isn't relevant, just make sure that you do them both. Then go back to the IAM console, go to Policies, and then in the filter box, just go ahead and type Lambda, locate the Lambda start stop policy that we created at the start of the demo, check the box, then click on Actions, and then delete that policy. And you'll need to confirm that deletion, so go ahead and do that. Go to Roles, and we'll need to delete the role that we created for this lesson. So look for EC2 start stop Lambda role, select that, and then click on Delete, and then confirm that deletion. And then finally, click on Services, go to CloudFormation, and you'll need to delete the CloudFormation stack that created these two EC2 instances. So select that and click on Delete and then confirm that deletion, and that will return the account back into the same state as at the start of this demo lesson. So I hope this has been useful. I hope this has given you some practical experience of exactly how event-driven architecture works, how the event bridge works, and how Lambda works. They've been simple examples, but they cover all of the theory and practical implementation that you'll need for the exam and to get started in the real world. But at this point, that's everything I wanted to do in this demo lesson, so go ahead, complete the video, and when you're ready, I look forward to you joining me in the next.